We are now with Dr. Rachel Meidl of the Baker Institute for Public Policy at Rice University. Thanks for joining us.
Thanks for having me.
So let's talk about an MRS ongoing event entitled Materials Needs for Energy Sustainability by 2050. You are part of a panel discussion entitled Enabling a Circular Polymer Bioeconomy. So tell us why this session is going on.
Well, as you know, plastics is a major crisis right now. We have an insurgence of plastic waste across the globe. And so, plastics are a ubiquitous part of our everyday society and a very integral component. I mean, it's used for lightweighting vehicles, which help in fuel efficiency. It helps preserve food. And many people don't realize that plastics is a really integral component of the energy transition and an input for renewable energies like solar panels and electric vehicles and batteries and so forth. But it is also a waste crisis. And so the panel discussion today, we're discussing how we can transition from a linear economy to a circular economy in ways that leverages the bioeconomy, making polymers more circular, how we can tap into biological resources. And then we'll be discussing issues like how can we increase the sustainability, and are these circular biopolymers actually circular and sustainable?
So basically 80% of the plastics we have produced in the past 70 years are in landfills or out there in the environment. This is a huge number. So what's the role of materials science in achieving a circular polymer economy?
Most of the focus for circular economy over the years has been on the end of life, waste management and recycling. So in a truly circular economy, activities move further upstream at the design phase. And that's where material science comes into play. Mm-hmm. In a circular economy, we can design and re-engineer plastics and polymers to have longer lifespans, to be more durable, to ideally have infinite recycling. And so that's the whole role of material science.
If we look back at a previous discussion back in 2018 on circular economy, one of the panelists pointed out the energy expenditure to recycle some of these materials exceeded the energy required to create them in the first place.
That's true. A lot of life cycle assessments show that plastics have greater performance than things like glass and plastics and fibers and steel. But we have to keep in mind that in assessing life cycle assessments, we have to look at the scope and the boundaries. And some life cycle assessments just look at production phase or manufacturing phase. Ideally, we want to look at the entire life cycle from cradle to grave. And so when we look at, when we compare different types of materials, what we really want to do is to have a broader systematic picture of all the impacts. And we have to just go beyond emissions. We have to go beyond just energy inputs. And so that's where things like sustainable life cycle assessments can come into play, where we integrate things like life cycle costing with a broader range of environmental impacts alongside things like social life cycle assessments, so we can get a true understanding of what those impacts are across society.
So let's go back to the panel that you're on this time around, and there's representatives from academia, national labs, and industry. Why is it so important to have all of these folks talking about this topic?
Well, the plastic waste crisis, it's a global issue. It affects everybody. I mean, like I said, plastics are an integral part of society, but the solutions are complex. There's not one silver bullet that can tackle this entire issue. And so having academics at the table, coupled with industry and governments, and even your average consumer, really broadens the discussion because it integrates diverse viewpoints, and that helps drive better policy solutions and better outcomes.
All right, Dr. Rachel Meidl, thank you so much.